on your paper. Practice problem, a random sample of 50 GLMN students was taken and their mean SAT score was 1250. Assume sigma equals 105. What is a 95% confidence interval for the mean SAT score of GLMN students? So I want to look through this first of what should you do as you read this problem. So marking on things. Just these first couple words, what should I mark?
50 random.
That's fine. It tells me it's a random sample. What's this going to be? What's taken and their mean? Anything there?
Just that you're using mean.
I'm using mean, I'm not using proportion. So SAT scores context. What is my 1250? We're not dealing with it yet, but eventually in problems, I'm going to be giving you a sentence, and it's going to have mu and X bar included. So I want to make a point from the beginning so that you understand. How do I know that this is X bar and not mu? It talked about my sample. So it talked about my random sample. It talked about how many are in my random sample. What is the mean that goes with that random sample? That's my X bar. And then it just flat out gives us sigma equals 105. And then what's important for the last sentence? 95%. So obviously this is one that I've made up and condensed down to where there's not much extra in there. I want to do one that's as watered down as possible to start with. Alright, so state. What do we do for state? What does it start with? So we want to estimate something. What is it that we're estimating? Which is the true mean what?
SAT scores.
And then so I'm defining my population within this. And then I just need to say how specific I'm going to be, which is I need to finish with 95% confidence. Plan. Method right now should be really easy because we only have one method. Eventually we're going to have options there. But so, how many samples am I taking? How many samples did I take in the problem? So this is a one sample. My goal is that I'm trying to, am I using Z or T? How do I know that it is a Z? I will tell you now that when I'm at the board writing stuff and I'm looking at what comes next, you're going to have to help me remember to write that. There's going to be tons that forget. It is a Z what?
Instead of sigma's unknown, is it T?
Uh-huh. We're making an interval right now. Eventually we're going to do tests and intervals. So eventually, wait, go ahead. And then how does it end? Or means. So right now this is very watered down because that's the only one we have. Eventually this can be 1 or 2. Eventually this can be a Z or a T. Eventually this can be an interval or a test. Eventually this can be means or proportions. Alright, now I need to check my conditions. What's my first condition? And I want to do this one right now because I think you don't know what to expect to do here. Where does it tell me random in the problem? So a lot of times it's going to say something like, but sometimes I do this and people get confused or people don't use it correctly. If I put quotations around it, what do I mean? That's exactly literally the way it said it. I have people who use that and it's not word for word from the problem. But I have to state that I understand that it is what? Random what? This one is random selection as opposed to assignment. So a lot of times this one's going to be something really general over here, and I just have to say, was it selection or assignment? So random is usually really, really easy to do.
How do you know this one's selection?
If a sample is selection, it would be an experiment if it were random assignment. What's my next condition? And I wrote out all of these options. You don't ever have to write out all the options. You just go to the one you're supposed to. So, what was my first option that we wrote down? Stated. Is it stated that my population distribution is normal? No. So, what's my next option? Central limit theorem. Does central limit theorem apply? Yes. And really, people who are better at making it flow here like to write something like, because of central limit theorem. I don't care if you just straight up write central limit theorem. What is central limit theorem? What is? And just like last chapter, y'all change that a little bit. Some people write that way. Some people write n is greater than or equal to 30. As long as you have your numbers in there and you're saying that it's greater than or equal to 30.
100.
That's 50. Some people write n equals 50, n equals greater than 30, or n is greater than or equal to 30, or this way. I don't care. And how do I have to finish that?
So we can use normal approximation.
Just making connections to understanding how things fit together. What below here was important for me to know that I can use normal approximation? What? The what? Your critical values. So when we did critical values, we had to use the fact that it was on that yellow sheet. Otherwise, we couldn't find that, which means we couldn't find how far away they were. So just making sure that you understand like the pieces connection there. And then what's my last condition? And now, from now until quite a while, it's pretty much going to be very consistent that our conditions are going to be random, normal, independent. That I always tend to write them in that order so that I stay consistent. The way you write that doesn't matter. How do I check independent?
10%.
What is the 10% condition? What is my lowercase n?
50.
The capital N has to be greater than or equal to 500. And so now I write there are at least 500 what?
J on next to
So now we actually check it for being independent. But what's the other reason we check 10% condition? So that we can use your standard deviation equation. Alright, do. What's the first thing I write down? I'm just gonna go in the order that I wrote them down last time. What goes here? X bar. What is my X bar?
1250.
What's my next thing?
Sigma.
Sigma, because it's sigma, not S, which is
105.
what else?
Little n.
Which is,
50.
and then
Confidence level.
what is our confidence level percent?
90%. Or
95. So yeah. Now, at this point, you're probably going to need to do a little bit of at least scratch work from there. Come tomorrow or the next day, you're probably not going to do much scratch work because you're going to have memorized really quick. Here's 95%. What do I do with 95%? 100 minus, which gives me 5%. What do I do with 5%? Divided by 2, so 0.0250. Which is 1.96. So are we doing Z or T right now? Why are we doing Z? Because we know sigma, and that is 1.96. So we've done 2 of them today that are 2 ones that you memorized pretty quick. 90% is 1.645, 95% is 1.96. Now, I don't have to write out the equation in words like I started with for your 4-step. I can go straight to the equation I'm using. So the equation I'm using is starting with what? All right, so what is our X bar? What is Z? What's sigma? Divided by square root. All right, my suggestion here, everyone type in this equation with minus. So type it in with minus, so 1250 minus 1.96 times 105 over square root 50. And what do you get? I don't have this one written down in front of me. What, 20?
12.
Wait, what?
8.
Is less than or equal to what symbol? Mu, because that's what we're estimating. So I have typed in this whole equation with minus, right? So instead of starting over, if I do second enter, it types that all again for me, and I just go back in, change my minus to a plus. And that's the way I would suggest doing this instead of doing it like in pieces and find what this is, then add it and subtract it. And then you end up getting what is your upper?
1279.1045.
Just for the sake of this being an example, point, score, something. This is one of those where it's weird, it doesn't have them, but I don't want you to look back at it. One thing that I want you to think about here, because you'd be surprised how many people miss this. I don't care what this problem is or what the numbers are. I know that this number over here is going to be what? What in relation to what? Less than my mean. I know that this number is gonna be what? Greater than my mean. And they're the same distance apart. So if I get something over here like 500, and I get 1279 over here, I shouldn't have to think much to realize it is something wrong. So like, pay attention to that, and you'll end up catching a lot of your mistakes. This should fit in between these two, and they should be equal apart. Alright, so all I have left is my conclude, which starts with what?
We are.
We are, what percent this time? What are we 95% confident that?
We,
Which is,
mean to SAT score for all geographies.
does what?
False discrimination.
And then what's our lower?
1,220.895.
And again, just for the sake of this being an example, point, score, something. And what was our upper?
279.0.5.
So, again, tedious process, yes. Have we really added that much? No. Hopefully this is easy at this point. Hopefully you see how this is going to be very repetitive from here on out. So understanding it now is really, 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 really important, because then tweaking tiny little pieces gets really easy. Questions right now?